Hi guys, it's Ian here. So this is going to be a video that'll cover that interpolation tutorial that we didn't get to. So I just want to run through it with this brief video so you can follow on in those notes that I handed out in that course that we did. So it'll be on your desktop still, on your laptops, in the GIS folder, the tutorials folder, interpolation. So we're going to be referencing the folders in this folder each time when we add layers and save out layers in the project. And if you want to look at the PDF, if you don't have your hard copy notes anymore, this is where that PDF is. So this is the tutorial that I'll be referencing. So I'm just going to step through the steps or run through the steps as I've set them out in this tutorial. So you'll get a chance to follow on with this, and just pause the video if you need to catch up anywhere, and yeah, just do it how you prefer, and if you have any questions, give me a shout when you've gone through it. Okay, so that's where we are. So first thing I want to do is open up the project from the projects folder. So it's tutorials, interpolation, projects, interpolation. Okay, and that'll open up this QGIS project, which has already been set out. It should open up for you guys. If it doesn't, give me a shout and I can try and problem solve there. So anyway, so what we want to do here is we've got a property which is on the coast, and it's got a number of different features. It's got some natural features, and then also a road, and then farm boundaries, and basically a project extent. And the idea here is that we want to determine what the slope is for this property, so that we can take it to the developers and tell them what the slope is, and identify areas that are developable because the areas are flat enough, or not developable based on the steepness of the slopes. So that's the idea behind this project and this tutorial. Right, so to determine slope, we need an elevation source. We don't have an elevation source in their project as it is. So what we're going to do is we're going to add a vector layer, the contours vector layer, and then build a surface model from that. So use the data source manager. I'm going to open the data source manager, and we are going to be adding a vector. So make sure that the vector tab is selected, and then navigate to the tutorial folder, and we want to have a look inside the spatial folder, vector, and you can set the type to Esri shapefile, and then select contours, and then select open, click add, and then close down the data source manager, and that'll open up a layer that looks like this. And if we open up the attribute table, we can have a look at all the columns in the attribute table and see where the height values are. Here's the height values, and looking at this, if I just sort it, we can see there are 5 meter contour intervals. So these contours are every 5 meters, and this is the layer we're going to use to create our DEM, or digital elevation model. And some of the tools we are going to use for this tutorial are in the processing toolbox, which we'll need to activate via the plugins menu. So select plugins, click manage and install, and then if it's not already turned on, just select the installed plugins and turn on processing. And then you can close that once that's turned on, and that'll give you a processing menu. So we can select the processing menu and then click on the toolbox, which will open and possibly dock, or this window could be floating. If it's floating, what you can do is just select it and drag it to the right hand side of your project view, and that'll dock it on the right hand side of your view. And what we want to do is search for a tool which is a interpolation. So we're going to go interpolation, and there's a couple that pop up. And the one we want to use first is the tin. We want to create a tin from the vector file. So click on you can double click on the tin interpolation, and that'll open up this little input window. And the vector layer, if it isn't selected, we're going to create the layer from the digital elevation model from is contours, and then the attribute. Remember, we looked inside that attribute table, and the attribute was height. And then we just need to make sure we add it to the window, or to this little expression here. So we're going to say add. So now this is the layer it's going to use to calculate the surface. And if you've run out of space, just drag your window down a bit bigger so that you can see a couple other options at the bottom here. And the next thing we want to do is we're not going to create a temporary layer, we want to create a permanent file. So just click on this little browse button next to save the temporary file, and then click save to file. So this is going to be a permanent file, and then navigate to the tutorials 5 spatial output folder, and in the output folder we're just going to call it DEM, and then click save. And before we click run, we just want to change a couple other settings. We want to set the extent for the new layer, and we're going to use the layer extent, and then select contours as your layer extent. And then we also want to change the pixel size. Currently a 0.1 pixel size is creating quite a few rows, and we don't want a pixel size that big. We'll change the pixel size to 5, which is going to be 5 meter pixels. It's going to use the same units as the input layer projection, or CRS. And now we can click run, and that should create our DEM. And that process shouldn't take too long, so you can click close, right click on your layer and zoom to layer. Okay, so before we continue, I just want to change the name of my surface model to the actual name as it is in the files, in our tutorial files. QGIS adds a name according to the process that was used to create the layer. So it's just a default layer name that's given to the layer. So I just want to change that so I'm not confused later, and I know that it is the DEM layer. So I'm going to rename it and just type in DEM. And then in the next step, I want to style this up into a different color. So I'm going to select properties, select symbology. Then from the render type, I want to choose single band pseudo color, and then choose an appropriate color ramp. Now you can choose any ramp here, one that looks like terrain, but I'll show you how to create one from scratch. So if I double click on the gradient, what I can then do is actually change these colors according to how I see fit, or what's going to be the best option for my model. And these stops with the colors are basically where the layer will change, where the gradient will change. Okay, so 5, based on the one we've just selected, 5 is the number that has come through with that default projection, or that default color ramp, excuse me. So I just want to add a new stop, so I just double click to add a color ramp. So that adds a new stop on the color ramp, sorry. And then I want to drag this to the I think it's 5% of the way down. So if I just type it in there, I can type in 5%. Right, so now what I'm going to do is actually adjust the colors. So I'm going to select the first stop, and I'll make that color a blue. So I'm going to double click on that stop. I'm going to change that color to an HTML color down here, and the color is 6F B 9 E3, and then push enter. So we've got a light blue color there. Then on the stop at 5%, whoops, I don't want that one, so I just need to delete that stop. Select this stop. Don't double click it, just click on it once, and then it'll allow you to change the color. I'll change that color to 769C5C and push enter. So there's a green color, and then click on this stop, which is sitting at 25 or around about 25%. So now that color is going to be, it is F2E79B, and these HTML codes are just codes that I've figured out are nice colors for topography. So you can double click anywhere on your, let's say, your little triangle, and that's where I'm getting the codes from. So you'll see as I change colors, you'll see the color code changes. Okay, so that's where I've got the colors from. These are not special codes that I can remember off the top of my head. They're just colors that I thought would be nice for this topography, and that's why I've used them in this example. So I just need to change that back to what it was just now, which was, what was it, F2E79B. That's right. So then you select the one at 50%, and we're going to change that to EDC585 and push enter. The next one at 75%, we're going to change to C28 C7C and push enter. Okay, so now you can see I've chosen blue because the values around 0 are ocean. I'm going to assume are either ocean or some kind of estuary, so that's why I want them blue. And then I set the 5% mark a green, so that the project, when it colors up, anything that's around whatever the elevation at 5% is will start being green and then move as it gets higher up into these different colors. Now this last one needs to be, I think we're going to make it close to white. And we'll select that one and change it to white. Would be 6 Fs, but we're just going to go with 3 Fs, and then it's a 2 and another 2 Fs, and push enter. You see it's close to white. There we go. So I'm quite happy with that color. And then we can just say OK. Then you can click apply and OK. And that's what our topography looks like. So you can see why I chose that blue color, because it'll show up where the ocean is and then the estuaries. We've also got our hydrographic vector layer sitting on top, which also shows the extent of the estuaries and rivers. And I think that works. So we're going to be happy with that one. We'll use that for our DEM styling. So the next thing we do is we're actually going to do a slope analysis using the DEM that we have created from the contours. So once again, in the processing toolbox, I'm going to type in slope. And then there's a couple slope options here. And we want to choose the one that is under raster terrain analysis. So double click on slope under that option. Actually, is it that option? Yeah, that's the correct option. I'm happy with that. And then make sure you choose the elevation data as your DEM. The Z factor, which is an exaggeration scale, will set at 1, so it's not going to exaggerate the topography in any way. If you chose 2 here, something like 100 meters would be 200 meters, etc. So by choosing 1, you can just keep it as is. You might use a different exaggeration factor if you were in a very flat area and you just wanted to highlight the topography so that you could get a better idea of what it actually looks like. I don't really use the Z factors. I'm usually happy with the 1-to-1 scale. Okay, and then in the output, we're going to save a new file, save to file, and in the output folder, we'll just call this one slope. Yeah, slopes is fine. And then we're going to click save and run and close. And then slope is added to the project. Okay, in QGIS, slope is measured in degree of inclination. So a 64-degree slope implies that it's not quite vertical. 90 would be vertical, and 0 degrees would be completely flat. So if we have a look at the tutorial, I think it's on one of these pages here. I'm just going to scroll down to come and find it. Okay, so if we're looking at calculating degrees of inclination, that's what the slope is being represented as. Okay, so what we can do is we can calculate a slope of 1 in 5. And in this example, we're going to assume that the restriction in slope is a slope of 1 in 5. Anything that's steeper than 1 in 5 is not going to be allowed to be built on. Anything flatter is available for development. So how do we calculate a slope of 1 in 5? We're basically looking at our little triangle here, a bit of trigonometry. If we want to calculate for tan theta, it's going to be y over x inverse of tan. So we can just do that quickly on our calculator. Calculator, not calendar, calculator. Okay, and that opens up calculator. Now if you don't see your calculator, if it doesn't look like this, you can go and change it from standard to scientific. Okay, so what are we doing? We want to calculate a y over x inverse tan. So it's 1 divided by 5, because for every 5 meters we go across, we're going to ascend 1 meter. So that's what a slope of 1 in 5 meters means. It means every 5 meters you move across, you're going to go up 1. So equals, and then we use the trigonometry function inverse of tan, and that gives us 11.3099324 degrees. So that is the angle we want to calculate for our slopes of 1 in 5. Right, so let's go back to our QGIS project, and that's what we're going to calculate for. And we will do that using the Raster Calculator. So under the Raster menu, we want to open up the Raster Calculator, and that's going to pop up with this window. And we've got two rasters in our project, the elevation model as well as the slope. So we want to calculate for slope. So we want to say our slope, so you double click on slope to add it to your expression window. So where your slope is bigger than 11.3099324, whoops, nothing happened there, 11.3099324, we want to calculate for all of those slopes. So that is the expression. But we just need to make sure we put it somewhere, so we're going to put it in our output folder again. So it is going to be desktop, here is tutorials, interpolation, spatial. I'm going to put it in the output folder, and I'm going to call this, what should I call this? Slopes 1 in 5. In the tutorial, I think I tell us to call it, let's just copy what it says in the tutorial, 1 in 5. Okay, so that's going to be the new raster name, and it's going to put it in an output folder. We're going to leave it as a geotiff, and the output coordinate reference system is going to be, I think we're choosing Zangi HB. So if you need to, just go and search for it. You can click on your little coordinate reference system window here, and then just type in Zangi, and we're going to use this one here. So HBK number 27. So you might need to go find it down here. It's this one here, and then say OK. So that's going to be the coordinate reference system for the project, or for the slopes layer, and then we click OK. And so what they should now do is have two categories for 1 and 0, where 1 is steep slopes and 0 are flat slopes. So what we can do is we can just compare using the contours. Alright, so 1 areas are steep slopes, and then the darker black areas are flat slopes. And just turn on, you can just turn on your contours just to make sure that it kind of makes sense. You can see where all the contours are really tightly packed and close together, those are definitely going to be steeper areas. And then where they're further apart with bigger spaces, you can see those are flatter areas. So we can see it is making sense. Okay, so currently our slopes layer is a vector layer. If we want, a raster layer. If we want to convert it to a vector layer, just select the from the raster menu. It's conversion. We want to polygonize raster to vector. So we select that option, and we're going to make sure you choose the right raster layer. The DN is the new column that's going to be created, and in that column you're going to get 1s and 0s. So now you'll know which ones are steep and flat, and we can just go and give it a new name and put it in that same output folder. Make sure you choose a shapefile, although other vector formats are also completely permissible here. We'll just choose the shapefile for this example. And what are we going to call this one? This one we can call slopes 1 in 5. Slopes 1 in 5. We can say save and then run, and then close. We can close down our 1 in 5 raster, turn off our contours. So this is just a direct it's a reflection of that raster. So it's polygonized each of those cells into various polygon features. So that's what we got here. So what we can then do is clip this vector layer out and start calculating areas. So you'll now be able to determine what percentage of your property is developable based on a 1 in 5 slope. So I'm just going to rename that so we know what layer it is. I'm going to call it slopes 1 in 5, and then I'll just color up on that DN column. So it was categorized, the column will be DN, so this is going to be 1 and 0 probably. Correct. We can remove the blank one. So steep slopes are going to be red, indicating that there's a bit of a warning there. What we can do is maybe remove the outline. So I'm just going to say no pen for the outline, and then green or maybe blue. We'll make blue slopes the acceptable slopes, let's say, and also no pen. We'll say OK, and then just change the layer rendering down to 50% or there and thereabouts. Say apply. Okay, so now we can see on top of that DEM, we can see which layers are steeper. So that the red areas are areas that are not developable. Okay, so that's just to give us an idea of how it looks. Right, so the next thing I want to show you is the Hillshade. Now, Hillshade is a raster. We can create a Hillshade raster that'll give a three-dimensional look to a topographical map. Or in this case, we'll turn on a Hillshade layer over the top of our elevation raster. So we're going to use the raster tools, and it is under analysis. Select Hillshade, and then the input layer is going to be our DEM again, the original elevation model. There's going to be no factor, which is exaggeration factor. We're going to accept actually I think we've got a slightly different one for the angle. No, we're not. We're going to accept the azimuth of 315 and the vertical angle of 45 degrees. You may want to change these depending on what your latitude is. But for the latitude we're working on here, which is around, 32 degrees south, these azimuths are acceptable. And we're going to name a new layer Hillshade. So we've got a new raster layer. So save and then run and close. And that's what it looks like. So now that you can see it's got a three-dimensional shape to it. We turned on those contours again, and you can see that that's the steep area. It looks like the river has cut into the bank here, so that's going to be a steep cliff area. There's a few other sand dunes running along the coast here, and it just gives the map a better look. And a very nice use of Hillshade is if you use Hillshade with the elevation data, and we'll just make this Hillshade layer slightly transparent. So we'll go to transparency. So I've opened up the Hillshade layer properties. I want to move this down to around, let's say 40%. Apply. And you can already see that now with the elevation data underneath it and the Hillshade, it gives it a three-dimensional look. And if I turn on the Hillshade, I'll turn that on and off. You can see what I mean by that. So it gives it a three-dimensional look. Okay, what's next? Okay, so for the next portion of this tutorial, we're going to use the IDW interpolation, or inverse distance weighted interpolation, to determine or approximate the water quality, the groundwater quality, using some borehole data. So we'll need to add those boreholes next. So I'm going to turn on open my data source manager and go and look for those boreholes, and they'll be in the tutorial folder, spatial vector. And it's a shape file, so I can just make sure I choose the right layer or the right file type. So choose boreholes, B-holes, and add, close. Okay, so now these are boreholes from around our property. If we open the attribute table, we can see that they've got, it's all the determinant that's been measured here is electrical conductivity, and the values are a low value of 25 to a high value of 600. So we want to use the interpolation method to approximate create a layer for water quality using this point file. So what the interpolation method will do is calculate what the water quality is between these 2 points, and we're going to use the IDW method. So what we'll do is we will in the processing toolbox, we're going to type in interpolation. It's the IDW interpolation, so we can double click on that to open it. The vector layer we're going to use is boreholes. The interpolation attribute is value, and we can add that to our little menu, and our distance coefficient is going to be 2. We'll set the extent to be the same as which one are we going to choose here? We're looking to choose the same as the borehole layer. That makes sense. We'll say OK. and then we want to save a new file. But before I do that, let's just change the pixel size to 10. That pixel size of 0.1 is just going to make a very big raster, which is going to take up too much space. So we'll just make that 10, so it's 10 meter blocks, and then we'll save it in that same folder, the output folder, and this one we're going to call EC for Electrical Conductivity, and click Save, and Run, and close. Okay, so there we go. So if I just put this interpolated layer underneath the boreholes and then just rename it to EC for Electrical Conductivity, we know what that layer is, and then possibly just color it up similar to the way the boreholes have been styled. So I'll just open the layer properties and then select symbology and then choose single band pseudo color, and then we want to use equal interval. I'm going to have 5 classes, and then I'm going to classify that. Okay, so now what I want to do is just change these colors so that they're similar to the borehole data. So I can also I just also want to change the values for those classes, and that's easy enough to do. You just click inside the value and then you can type in the value. So the first value I'm going to type in is 70, and then 150, 150, 370, so these correspond to the borehole values, 520, and then everything in above 520. So now this label we can change. So now the label won't affect how it renders, it's just how it's going to be displayed in the legend. And this is 70 to 150. So then 150 to 370, and 370 to 520, and then everything greater than 520. You can maybe put a space in here as well. Okay, and the last thing we need to do is just change the colors. So we'll just go ahead and choose similar colors to those. So 70, we'll just go with a blue. That's fine. The next one will be like a bottle apple green, something like that. And then the next one is a yellow. The next one is pink. That looks good. And the last one is purple. So that's, you can see how that's corresponding to the borehole colors. Where's purple? Decent. A little darker. Can go that side. I'm not entirely happy with that purple. I don't want it to be too dominant, but you can tweak these colors whatever suits, and then say okay. Actually, you see now I think that's it's not too close to pink. Maybe it could be a little darker, to be fair. That's a little bit better. Okay, so there's a bigger contrast between pink and purple there, and that's it. And we can say apply and okay. And now looking at this interpolated water qualities raster, we can see that the blue and green areas have got low electrical conductivity, and then the purple areas have high conductivity, which indicate that these areas may have a higher pollution to those areas. So this water quality, groundwater quality layer, we can see that for our site, the green areas, according to the interpolation, have a better water quality than the purple and yellow areas. And that's pretty much the end of that tutorial. Yeah, run through it. Let me know what you think. And if you have any questions, I'm more than happy to answer them. And chat to you later. Cheers.